if I'm looking at the example y equals 2 to the power of x, does this look like a linear equation?
No, because
No.
it's missing the B.
Right? Not only that it's missing the b, usually it's 2 times, right? That would be linear,
Oh.
right? In this case, I have 2 to the power of x. What do we call this? Exponential, that's right. So the line is not going to be straight line. It's going to be a curvy line, right? Can you guys explain to me, if you remember, or if you know, how would it look like? How would the graph, like how are you, if you're imagining it right now in your head, how are you going to imagine it?
From negative to a positive, from left to right.
Like this? Okay, like this, which way? Like this? This?
What,
Yeah.
problem?
Like which one? Like the parabola? Okay, 9/11. Is it gonna be a parabola?
With the exponent?
This one, yeah.
Oh yeah, just put parabola usually. No? It's not?
No. What would, a parabola would have to be what degree? Degree 2, right? A parabola would be like if you have x squared, right? In this case, you have 2 to the power of x. So how would it look like? It's a curve. It's gonna look like this, right? Or it's gonna look like this, right? It's an increasing or a decreasing curve depending on what do I have, okay? So this is my expectations. This is what it should look like. Now let's see, we have to do a table of value. We're not gonna be guessing and whatever, right? So table of value for x. Remember, x is your exponent, right? So you can pick negative values, you can pick positive values. I know you probably will not remember this, but if you have 2 to the power of negative 1, right? Put that on the calculator for me, please. What do you get? 0.5, right? Are you surprised that it's 0.5? Did you get it? What did you get?
have to teach me how to do that. I remember. This is the only
Okay,
one.
2. And this is, and 1 equals 0.5. Now, why is that? Why is it 0.5?
Technically, it's 1/2.
It's 1/2. Yeah.
That's what.
Yeah. Whenever you have a negative exponent, you flip your base. Okay? So in exponential, this is your base, right? And this is your exponent. So in this case, your base is 2, your exponent is x, right? Whenever I have a negative, I will re-explain this. We're gonna have a whole chapter again on exponential. We did it in grade 11, but we're reintroducing grade 12. So what happens with a negative exponent, right, is it actually makes the base flip. So the base is 2/1 to the power of negative 1. It flips the base, it becomes 1/2, and it makes your exponent 1. Positive. Okay? Let me show you another one. So let's say if you have 2 to the power of negative 3. Right? If you write that as positive exponent, you flip the base, so it's 1/2 to the power of 3, which is 1/8. Okay? So when you have I need this paper. Here. Okay, I don't want a big one. This is okay. So this is basically exponential is always. I always like to talk about folding a paper, right? So let's say if you're doubling, right? How many faces do I have right now? One face. If I fold it in half, how many faces do I have? 2 faces, right? So that's my first fold. If I fold it another time, how many faces would I have? 4. If I fold it one more time, how many faces do I have? is 8. I have 8 if you actually count them. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 faces, right? So I'm doubling the faces every time I fold, right? So that means if I have 2 to the power of 0 with no folds, I have no folds, I'm gonna get 1. If I have 1 fold, I'm gonna get 2. If I have 2 folds, I'm gonna get 4. If I have 3 folds, I'm gonna get 8. Are we okay with that? Now, going back to my no fold with 1 face, right? If I actually split it in half, how many faces do I have? I have half of the face. I don't have that. I have half of it now, right? If I repeat another time, so that's basically when I start introducing my negatives. So if I have 2 to the power of -1, right? That means I have half of the face left, right? Repeat means power of -1. If I repeat again, right? I have quarter of the face left, right? So if I have 2 to the power of -2, I have quarter, right? If I repeat again, I have 1/8 of the face left, okay? So this is basically what it means, okay? The technical math of it, how can I do the math is whenever I see a negative exponent, I flip my base and make my exponent positive. Okay, so what's your original base here? What's your base here? 2, right? So 2, but it's to the power of -1. Okay? The base is 2, but it's technically 2 over 1, right? Any whole number is 2 over 1, right? It's over 1. So if I flip it, it becomes 1 over 2. So I make the denominator numerator and the numerator denominator. And then I make my exponent a positive. Okay? Now if I have something that looks like this, let's say 2 over 3 to the power of -4. Okay? If I want to make this positive, it becomes, with the base, so it becomes 3 over 2 to the power of 4. That's what fills the base. Okay? Are we all okay with that? Okay. Now, if I want to, I'm going to erase the whole thing. So if I want to make a table of value of this, do I want to choose too many negative values? No, because technically the higher the negative value, the smaller the number is. It's going to be like 0.02 and then 0.2 and 0.5, right? So it's going to be very hard to graph on my graph. I will have at least 1 or 2 just so I can see how my graph's going to look like, but most of my numbers that I'm going to pick for x, they're going to have to be positive numbers. Okay? So remember that when you're doing your table of value, you have to pick your x. Is that correct? Yeah? So if I want to pick my x's, I have to do a study before I pick my x's, right? I have to think about what x values I want to pick. In this case, I don't want to pick too many negatives, right? Because remember, if I have 2 to the power of -2, it's going to be 1 over 2 to the power of 2, which is 1 over 4, which is 0.25, right? Try grabbing 0.25 on your graph. Where would it be? Somewhere right here? Yeah? But how accurate can you be? You're not going to be accurate, right? So that's why we don't pick too many negative values. So let's pick -1, 0, 1, 2, and 3. Now, if I do 2 to the power of -1, what did I say we're going to get? 0.5 or 1 over 2. If I pick 2 to the power of 0, what do you get? Do that on the calculator. I want to hear it. 1. Anything to the power of 0, no matter how big it is, no matter how small it is, even if it's a letter, to the power of 0 is 1. You can try it on your calculator and tell me if you're going to get that. Okay? So, to the power of 0, anything is 1. Good. 2 to the power of 1.
2.
2 to the power of 2. 2 to the power of 3. 8. What's happening here? What's happening to my numbers?
Doubling.
They're doubling. They're double, right? So this is an exponential. We call it growth because it's growing. And technically, the correct word for it is doubling in this case because my numbers are multiplying by 2. Okay? So if I want to graph this, are you guys okay with this? So my 0.5 is right here at -1. And then if I have 0, 0 is 1. 1 is 2.
Maya,
2, yep.
at any point in time we're finding a table of value. Would you recommend that we stick with as less negative numbers as possible
In exponential, yes.
in exponential?
Yeah, and it all depends on what base do you have. So if you have a base that's greater than 1, then yes, you're gonna stick with a positive value. If you have, well, I'm gonna talk about the next base, okay? Just give me, I will explain in B.
So
Okay.
this is exponential. The one before was
Linear, in what? In here? It's just to shape the graph on the other side. We don't need it, it's just to shape it. Okay? So if I have 2, it's gonna be 4. And at 3, it's gonna be at 8. So we see that it's not a line, it's a curve. Now, before I move on, I don't like to leave my graph like this, right? I wanna know what the end. So we talked about like as you go to the negative, you're ripping out the paper, right? You're taking part of it out. So we talked about that if I rip it 3 times, it's 1/8 of it, right? If I rip it 4 times, it's gonna be 1/16 of it. If I rip it 5 times, it's gonna be 1 whatever of it, right? If I keep ripping it, I'm gonna keep having part of the piece of paper, right? No matter what, I can still keep ripping that paper and I'm gonna still have a piece of it. It's gonna be a very small piece, it's gonna be a microscopic piece where you need a microscope for it, but it's never gonna be, it does not exist. It's gonna be a small piece, but it's not gonna be a 0. I'm always gonna have a small part of it. I can go deep inside the paper and start removing molecules out of it. Okay? So, that being said, that my graph right here is going to get close and close to that 0 line, but it's never gonna touch it. It's never gonna be 0. That piece of paper is never going to be non-existent. You can go down to the atom if you want. Okay? So that's why it will never touch that 0 line. Okay? And this is how we know it's exponential. We know it's exponential because it has a flat surface on one side, and then as it goes up, in this case, you're increasing rapidly. Right? After the 8, I'm going to jump all the way to the 16. After the 16, I'm going to jump to the 32. After the 32, I'm going to jump to the 64. So you see that my numbers are going to be jumping rapidly after that. Are we good with that? Good. So the base in this case was what? What was my base? 2. My base was 2. 2 is a greater number than 1, right? 2 is greater than 1? Good. What did I say we call this? Exponential growth. and you see a growth, right? If you study biology or chemistry or any of the sciences, the exponential growth is a example that will show up many times, because like the number of bacteria, they usually double or triple every certain time, right? Or even if you're studying chemistry and then you're trying to study the radioactive material in a certain substance, and then you study it, it's usually either an exponential growth or decay. It's exponential. So you will see that exponential in many different areas, especially in the science. Okay? Now, what determines an exponential growth or an exponential decay?
Points?
And where are the points coming from? Why is it growth and why is it decay? So any base higher than 1 is going to be considered growth. Any base that's between 0 and 1, so it's a half, or a third, or a fourth, or 2/3. Okay? So any number which is your base, if your base is greater than 1, so it's a growth. If your base is between 0 and 1, okay, so let's say examples would be half, 2/3, 0.75, I don't know, like I'm just giving some examples here, okay? That would cause a decay. That's 0.75. So that's going to be a decay. So you're going to start big, and then you're going to start reducing. We're good? Okay. An example of an exponential decay would be, let's say you are sick, you need an antibiotic, and they tested you, you have this amount of bacteria in your body, right? And they give you antibiotics, so you kill it, right? So what happens is you're starting with a big number, and then every dose you take, or every hour after the dose, the number of bacteria is going to be decrease, right? Because it's going to die, right? And that would be an example of an exponential decay. Okay? Or even like when you take, let's say, when you drink caffeine, right? The caffeine in your blood at the beginning, it's going to be high up. And then as you go during the day, it's going to start decreasing, and then that's also can be considered as an exponential decrease. We're good? Okay. Now, if I have the equation, which is y equals 1/2 x, I think that's the question, right? It's 1/2 x.
Yeah.
To the power of x, I mean. Now, if I want to make a table of values, right? If I pick positive values, what do you think I'm going to get? I'm going to get a lot of decimals, right? So think about it this way. If I have a half to the power of 1, what do I get? A half. Half to the power of 2 is?
1.
No, it's quarter. You're multiplying a half by itself, right? So half to the power of 2, that will be 1/4, which is a quarter. Are we okay with that?
So you flip it regardless
Okay.
if it's
Think about this. Half times a half. That is 1/4, right? Yeah? What if I have a half to the power of 3? What do I get? 1/8, right? So the number is getting smaller and smaller as I'm increasing my exponent. So is picking a positive value a good idea? No. Because the number is getting small. So this is where I'm going to make the decision of picking negative numbers. What happens when I have a -1? What's going to happen to my base? Flip the base, become positive. So now my base is what? That's right. So that's 2 over 1, which is 2, to the power of 1, so that's 2. So in this case, negative numbers are better option. Okay, this is when you're picking your numbers. Okay, so let's do a table of value for them. Oh, I have to do the table of value. Yeah, I'm not really sure. So I'm gonna pick -3, -2, -1, 0, and so if I have 1/2 to the power of -3, flip the base, 2 to the power of 3 gives me 8. We're okay with this. Flipping the base gives me 2 over 1, right? Positive exponent now, so 2 to the power of 3 is 8. We're good? If I have 1/2 to the power of -2, what do I get? 4. Again, flip the base, that gives me 2 to the power of 2 is 4. 1/2 to the power of -1. 2. 1/2 to the power of 0. Anything to the power of 0 is 1. 1/2 to the power of 1. It's 1/2. You don't flip. You don't have a negative exponent. You don't flip. Right? Exponential decay or exponential growth? Decay. That's right. You see that the numbers are decreasing, right, as x is increasing.
Maya,
Yes?
you only flip the numbers when it's a negative,
That's correct. When you have a negative power, that's the only time that you're gonna flip your base. And then as you expect, the more numbers I have, and I've already talked about this, the smaller the number is gonna get, so we're gonna go with a flat just one second.